our first objective in thermochemistry, we are being asked to use the relationship between mass, specific heat, and the temperature change to calculate the heat flow during a chemical or physical process. The relationship between heat, which we represent with Q, can be found by calculating the mass times the specific heat times the delta T, our change in temperature. Given the mass, specific heat, and delta T, we calculate Q, which is our heat. Let's read through our first question. The specific heat of iron metal is 0.450 joules per gram Kelvin. K stands for a Kelvin unit. Even though our temperatures will be given to us in degrees Celsius, don't let that bother you. A Kelvin unit and a degrees Celsius unit will show us the same change. Joules per gram Celsius is also a correct unit for specific heat. So here we are being told the specific heat value, which is C, 0.450 joules per gram. And why don't we go ahead and think in our head degrees Celsius? How many joules of heat, that's asking us to solve for Q in a joule unit, are necessary to raise 1.05 kilogram block of iron? The kilogram unit will need it to be converted to a gram unit. We would do that by saying that there are exactly 1,000 grams in every 1 kilogram. So we'll need to slide our decimal 3 spots to convert kilograms into grams. The delta T can be found by simply taking T2, which is 88.5, minus the 25 T1. It's a plug and chug formula. Given the mass, the specific heat, and the delta T, we'll calculate Q. The mass, again converting, 1.05 times 1,000. Hit that on your calculator, and you've converted a kilogram into a gram, and we would see that's 1050 grams. Specific heat of iron given to us is 0.45 joules per gram degrees Celsius. And T2 minus T1, that's 88.5, minus the 25 shows us a delta T of 63.5 degrees Celsius. M times C times delta T shows us heat energy measured in a joules. Hitting for this, we show on our calculator 1050 times 0.45 times 63.5, and I'm showing a value 30003.75 joules. Q is 30,003.75 joules of energy.